Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Stratified Sampling. If you need any extra help on Stratified Sampling, if you go to the Corbettmaths website, go to the Videos and Worksheets section and scroll down to video number 281. There's a dedicated video tutorial there on Stratified Sampling. Alternatively, you can scan the QR code on the front of this booklet. But in this video, we're going to go through the video solutions to the practice questions, so let's get started. Okay, so question number one. Question number one says the table shows information about the inhabitants of a village. And we've got their ages between 0 and 20, there's 693 of those. Between 21 and 40, there's 1,203 people. Between 41 and 60, there's 802 people. And over 60, there's 405. And then we're told that Bernard's going to carry out a survey about the local library, and he wants to find out how often people have been to the library in the last year. And Bernard decides to take a stratified sample. And part A says, explain why it's appropriate to take a stratified sample. Well, if we have a look at the groups here between 0 and 20, 21 to 40, 41 and 60 and over 60, these four groups have got quite different population sizes. For instance, there's a lot more people in this group, the 21 to 40 group, than the over 60 group. There's 1,203 of those, but only 405 of those. So it wouldn't make sense to ask the same number of over 60-year-olds as between 21 and 40-year-olds. So what we would do is we take a stratified sample to keep the sample in the same proportions as the population. So let's write that down. And that's it. So I've explained that there's a significantly different amount of people in each group. So therefore it makes sense to take a stratified sample so that the sample is representative of the numbers of people in the groups. And then if we carry on, we're told Bernard takes a stratified sample of 100. And we've been asked to calculate the number of people in each age group that Bernard should choose. Okay, so remember, to do a stratified sample, we use the formula number in category over total times sample size. So in other words, writing down the fraction of the total number of people in each of the categories and then times that by the sample size. So if we start off with the 0 to 20 age bracket, if we go back up, there's 693 of those. So that's going to be the number in the category. And let's find the total. So let's add together the frequencies. So 693 plus 1,203 plus 802 plus 405 is equal to 3,103. So that's the total. So that's going to be the denominator. On the numerator will be 693. So it's going to be 693 out of the 3,103 times by the sample size, which is 100, because we're told that Bernard wants to take a sample of 100. So let's write that down. So 693 over 3,103 times by 100. And when we work that out, we get an answer of 22.333 and so on. So I'm not going to round that yet, I'm just going to leave it like that. And now what I'm going to do is I'm going to do the same for the 21 to 40 year olds, the 41 to 60 year olds and the over 60 year olds. So 21 to 40. The number in that category was 1,203. The total is still 3,103. And the total sample size is 100. And then if we work that out, we get an answer of 38.7689 and so on. Okay, so we've done the next group. Okay, now the 41 to 60 year olds. The number in the category was 802 divided by the total, 3,103, times by the sample size, which is 100. And when we do that, we get an answer of 25.8459 and so on. And then finally over 60. So over 60s, the number in that category was 405 divided by the total, which is again the 3,103 times by 100, and that's equal to 13.0518 and so on. Okay, so that's fantastic. So we've now worked each of these out. Now we need to choose how many people should be in each category. Now, we need to be careful here. If we round these numbers, you might find that they don't add up to the 100. And it's very important that we make sure that the sample is 100 because that's the sample size that Bernard wants. Okay, so let's have a look at these numbers. And let's just say if we were to round them like we would normally round numbers, what would we have? So if we use 22, that would round to 22. That would round up to 39. That would round up to 26. And that would round down to 13. And if we were to use 22, 39, 26 and 13, let's check and see if these add up to be 100. And if not, then we'll need to adjust it. So let's do that. So 22 plus 39 plus 26 plus 13 is equal to 100. Fantastic. So actually we can just round them like we would round our numbers normally. But just be careful. If we rounded them and perhaps whenever we added them up we got 101, then we would need to choose one that we wouldn't round up and then to make sure it added up to be 100. So we're going to have 22, 0 to 20 year olds. We're going to have 39, 21 to 40 year olds. 26, 41 to 60 year olds, and 13 over 60-year-olds. And that makes sense because if we have a look here, remember earlier on, whenever we talked about why we used a stratified sample here, we said, well, there's 1,203 people between 21 and 40 and only 405 over 60. So as you can see, there's nearly 3 times as many 21 to 40-year-olds as there are over 60-year-olds. And if we go down here to our sample, we've got 13 over 60-year-olds and 3 times as many, which is 39, 21 to 40-year-olds. So that makes sense. We're asking 3 times as many. So the sample is representative of the population. So let's have a look at our next question, question number 2. So question number 2 says there's 180 employees in a school and the table shows each type of employee in the school. So we've got 94 teachers, 16 teaching assistants, 41 admin staff and 29 other staff. And the question said a stratified sample of 50 is required and calculate the number of each type of employee that should be chosen. So obviously here, with there being 180 employees and there being 94 teachers, it wouldn't be fair to survey the same number of teaching assistants as there would teachers, because obviously there's a lot more teachers than teaching assistants. So remember, to work out a stratified sample, to work out how many people should be in each category, we do the number in the category divided by the total times the sample size. The sample size is 50, the total is 180, so we're going to do 94 divided by 180 times 50 to find out how many teachers we need. We're going to do 16 divided by 180 times by 50 to see how many teaching assistants we need. We're going to do 41 divided by 180 times by 50 to see how many admin staff we need. And finally, we're going to do 29 divided by 180 times by 50. And that tells us how many other staff that need to be surveyed. And then when we do that, we'll have a look at the numbers and see how we're going to round them so that we get a sample size of 50. So let's do that. And when we do 94 divided by 180 times by 50 for the teachers, we get 26.111 and so on. Let's now do the teaching assistants, so the TAs. So we're going to do 16 divided by 180 times by 50, and that's equal to 4.444 and so on. We'll do the same for the admin staff, so the admin, and that's 41 divided by 180 times by 50, and that's equal to 11.3888 and so on. And finally the other staff, that's 29 divided by 180 times by 50, and that's equal to 8.0555 and so on. Okay, so worked out those numbers. Let's see now how we would round them to make sure that we get a sample size of 50. So if we were to use 26, 4, 11 and 8, just rounding them how I would normally round numbers, so rounding down, rounding down, rounding down, and rounding down, we'd get 26 plus 4 plus 11 plus 8 is equal to 49. So if we round them all the way we would normally round numbers, we get that's equal to 49, but there has to be a sample size of 50. So we're going to choose one that we're going to round up. And the good thing is, whenever you're dealing with stratified sampling questions like this, the exam board are quite flexible in terms of which one you choose, because you know, I might choose the TAs here, some people might choose the admin staff, but we're going to choose one that we're going to round up, and you don't need to worry too much in terms of which one you're going to round up, as long as, you know, I would tend to round up the one with the highest decimal part if it was me. So I'm going to round up the one that's the TA here, and if we had 4.444, I'm going to round that one up to 5, I'm going to round that one down to 26, that one down to 11, and that one down to 8. And let's just check that. So I'm just checking again. 26 plus 5 plus 11 plus 8 is equal to 50. Fantastic. So I'm going to survey 26, or the school should survey 26 teachers, 5 teaching assistants, 11 admin staff, and 8 other staff. And that's it. Okay, then we have a look at our next part, part B. It says describe a method to obtain a stratified sample of 50 from the employees in the school. So in other words, now we know that we need to have 26 teachers, 5 teaching assistants, 11 admin staff and 8 other staff. How would we actually pick them? So one approach would be to get all the names of the teachers. So we could get the 94 teachers and write all their names on a piece of paper, put them all into a hat and choose 26 at random. Put the 16 teaching assistants' names on pieces of paper, put them into a hat and pick 5 at random. Put the names of the 41 admin staff into a hat and pick 11 of those at random. And finally, put the names of the 29 other staff into a hat and pick 8 of them at random. And then that could be one way of choosing the members of staff that are going to be surveyed. Another way could be to number the staff. So number the teachers 1 to 94, then the teaching assistants 95 to whatever number that would be if there were 16 of them, and the admin staff and the 29 other staff, so they're numbered from 1 to 180. And then choose 26 numbers at random between 1 and 94. Choose 5 numbers at random between 95 and whatever number that would be, and so on. And that's another way. And I'm going to write down one of those approaches now. So I've just written down that I was assigning each member of staff a number, e.g. the teachers from 1 to 94, teaching assistants from 95 to 110, and so on. And then we would choose 26 at random between 1 and 94. We would choose 5 at random between 95 and 110, and so on. And that's how I'd obtain the stratified sample of 50 from the employees in the school. Okay, let's look at our next question, question number 3. So question number 3 says the table shows the home countries of rugby referees on a course. There's 8 referees from Ireland, 28 from Wales and 44 from Scotland. And David wants to take a stratified sample size of 10 from the referees. So he wants to take a stratified sample of 10 of these referees. And we've been asked to calculate the number of referees from each country that David should select. Okay, so one approach would be to work out the total. So let's work out the total. So 8 plus 28 plus 44. And it's a non-calculator question. So actually 8 plus 28 plus 44 is equal to 8 plus 8 is 16 plus 4 is 20. Put a 0 down and carry a 2. And 2 plus 4 is 6 plus 2 is 8. So there's 80 referees altogether. Now he wants a sample size of 10. So one approach could be to do 8 divided by 80 and times by 10, 28 divided by 80 times by 10, and 44 divided by 80 and then times by 10. Now there is another approach, because remember that a stratified sample is in the same proportions as the population. So here there's 80 referees altogether, and we want a stratified sample of 10. So if we divide the total by 8, so if we divide by 8, that would give us the sample size. So if we do 80 divided by 8, we get the sample size. If we divide each of these numbers by 8, that'll tell us how many referees he should select from Ireland, how many referees he should select from Wales, and how many he should select from Scotland. So let's divide each of these numbers by 8. So for Ireland, we're going to take our 8 and divide it by 8. So 8 divided by 8 is equal to 1. For Wales, we're going to take the 28 and then divide that by 8. Now remember, it's a non-calculator question, so we could use the Bushels method, or I'm just going to half it, and half it again. So half of it is 14, half of that is 7, and half of that is 3.5. This is 3.5 from Wales. And in terms of Scotland, we're going to take the 44 referees from Scotland and again divide that by 8. And remember, we're dividing by 8 because the population is 8 times bigger than the sample. So if we divide the population by 8, we get the sample size. So 44, we're going to half it, and half it again. So half of it is 22, half of that is 11, and half of that is 5.5. So that means that David should choose 1 referee from Ireland, but in terms of Wales and Scotland, we're going to have to round these because you can't take 3.5 Welsh referees and 5.5 Scottish referees unless one of the referees is half Welsh and half Scottish. Okay, so in terms of this, what we're going to do is, well, let's round these. Now, if we rounded them up, both of these numbers up, we'd have 1, 4, and 6. Well, 1 plus 4 is equal to 5, plus 6 is 11, so that'll be too many. So I'm going to choose one of these to round up and one of them to round down. Now again, it doesn't actually matter which one you choose as long as the sample size is 10. The mark seems quite flexible with that. So what I'm going to do is I'm going to choose 1 referee from Ireland. I'm going to round this one. I'm going to round this one up to be 4, and I'm going to round this one down to be 5. Because if we have 4 Welsh referees and 5 Scottish referees, when we add them all together, we get 10. We could have chosen 1, 3, and 6, and that would work as well, but I've just gone for 1, 4, and 5. And that's it. Okay, let's look at our next question, question number 4. Okay, let's look at our next question, question number 4. And again, it's a non-calculator question. And we're told there's 300 students in years 7, 8, 9, and 10 at a school. And here we've got the number of students. So 72 year 7s, 108 year 8s, 66 year 9s, and 54 year 10s. And a stratified sample of 50 is planned. So they want to take a stratified sample of 50. And the question says to calculate the number of people that should be selected from each year group. So how many people should be in the sample from each year group? Okay, now this is a non-calculator question. If this was a calculator question, I would do 72 divided by 300 times by 50, and then I'd get that number, and then I'd repeat that for year 8, so I'd do 108 divided by 300 times by 50, and so on. But because this is a non-calculator question, I'm going to look and see if there's a bit of a shortcut. So here we've got this 300 students, and the stratified sample is 50. To get from 300 to 50, we divide by 6. If we take 300 and we divide that by 6, we get that's equal to 50. So that means if we divide all these numbers by 6, that'll tell us how many should be in the sample. So let's divide them all by 6. So we're going to divide them all by 6, so divide by 6. So 72 divided by 6 is equal to 12. So there should be 12 year 7s. Let's have a look at year 8. So we're going to do 108 divided by 6. And I'm just using the Bush-Schultz method here. How many 6s going to 1? 0 remainder 1. How many 6s going to 10? That's 1 remainder 4. And how many 6s going to 48? That's equal to 8. So that's 18. And then year 9, we're going to divide by 6. 66 divided by 6 is equal to 11. And 54 divided by 6 is 9. So that means that it should be 12 year 7s chosen, 18 year 8s, 11 year 9s, and 9 year 10s. And that's it. And let's just check they add together to be 50. 12 plus 18 is 30, plus 11 is 41, plus 9 is 50. And yeah, that's right, they add together to be 50, so that's fantastic. Okay, let's look at our next question, question number 5. Okay, let's look at our next question, question number 5. So question number 5 says, Declan works in a confectioner's and he's going to test a sample of 40 chocolates stratified by the type of chocolate. And the table shows the number of each type of chocolate in the shop. So 600 milk chocolate, 220 dark chocolate, and 130 white chocolate. And the question says, calculate the number of dark chocolates required for his stratified sample. So let's work out how many chocolates there are all together. This is a calculator question, so that's quite nice. We can just add together 600, 220, and 130. And when we do that, when we add those together, that's equal to 950. So there's 950 chocolates all together. Now we want to work out how many dark chocolates are in the sample. So that's going to be the number in that category, 220, divided by the total, 950, times by the sample size, which is 40. And when we work that out, let's see what we get. So 220 divided by 950 times by 40 is equal to 9.26315 and so on. And let's just round that to be 9, and that's it. And so how many dark chocolates are in the sample? Our answer is 9, and that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6 says the table shows information about the vehicles sold by our dealership. So 677 cars are sold, 109 vans are sold, 82 motorbikes are sold, and 14 camper vans are sold. And the manager takes a sample of 50 customers, stratified by the type of vehicle sold. And we've been asked to calculate the number of each vehicle type in the sample. So we want to find a stratified sample. So let's work how many customers there are all together. So let's do 677 plus 109 plus 82 plus 14, and that's equal to 882. So that's the total, 882. And then if we want to work out the stratified sample, we're going to do the number in each of the categories divided by 882 times by 50. So let's do that. Okay, so I've just worked out each of them. So for the car, we've done 677 divided by 882 times by 50. We got that's equal to 38.378 and so on. For the van, we've done 109 divided by the total times by 50 and so on. So we've got each of those numbers and we want a stratified sample of 50. So let's see if we round them what they should be. So in terms of the caravan, that would go to 1. In terms of the motorbike, let's round that up to be 5. In terms of the van, let's round that down to be 6. And in terms of the car, let's round that down to be 38. And let's just check and see if that works. So if we do 38 plus 6 plus 5 plus 1, that's equal to 50. So that's right, 38, 6, 5, and 1. So that's it. We've got a stratified sample of 50 by each of the vehicle types. So 38 cars, 6 vans, 5 motorbikes, and 1 caravan. Okay, let's take our next question, question number 7. Okay, let's look at our next question, question number 7. So question number 7 says there's 300 passengers on a flight and each passenger sits in an economy, business or premium seat and a stratified sample is taken. And the table shows some information. So here we've got our economy, business and premium, and we've got some information in terms of the number on the flight and the number in the sample. So here we've got 60 people in premium and 108 people in business. Let's work out how many people are in economy, because there's 300 passengers altogether. So that means that this number, and this number must add together to be 300. So let's do 108 plus 60, and that's equal to 168. And then if we do 300, take away 168, that's equal to 132. So that means there's 132 economy passengers on this flight. Okay, now what we need to do is work out how many economy passengers are in the sample and how many premium passengers are in the sample. So what we notice here is that we've got the information on how many business passengers are on the flight and how many business passengers are in the sample. There's 108 business passengers on the flight and there's 18 in the sample. Now just remember that a stratified sample is in the same proportions as the population. So what that means is that all of these numbers have been divided by a particular number to get the number in the sample. So here, to get from 108 to 18, let's figure out what we're dividing by. So let's write down the multiples of 18. So 18, 36, 54, 72, 90, 108. And that's 1, 2, 3, 4, 5, 6. So that means that that number is being divided by 6. And if that number is being divided by 6, so is this number and this number. So 60 divided by 6 is 10. That's quite easy. And then 132 divided by 6. So 132 divided by 6. So how many 6s is going to 1? 0, remainder 1. How many 6s is going to 13? That's 2, remainder 1. And how many 6s is going to 12? That's 2. So it means there's 22 economy passengers in the sample. And that's it. Okay, let's look at our next question, question number 8. Okay, so question number 8. Question number 8 says a cricket club has got 400 members and a stratified sample is taken by age group. So we've got these age groups, 0 to 17, 18 to 39, 40 to 59 and 60 plus. And we're told a stratified sample of the members is taken by age group. So a stratified sample is taken. So remember the stratified sample is going to be in the same proportions as the population. And then it says the table shows some information and we've been asked to complete the table. So we need to work out these missing numbers here. Okay, so what I'm going to do is I'm going to focus on this age group here, 18 to 39, because the number of members is 100 and the number in the sample is 20. So that's being divided by 5. So divided by 5. So that now means we can work out this number by timesing by 5, this number by dividing by 5, and then we can then work out the missing numbers here and here. Okay, so let's work out this number here. This number, so there's 15 0 to 17-year-olds in the sample. So if we times 15 by 5, we'll find this number. So 15 times 5. So 10 times 5 is 50, and then 5 times 5 is 25, and if we add them together, we get 75. So it means there's 75 members between 0 and 17. Okay, now let's work out this number here. Well, to get this number, we're going to divide by 5. So let's take the 120 and divide by 5. So how many 5 is going to 1? 0, remainder 1. How many 5 is going to 12? That's 2, remainder 2. And how many 5 is going to 20? That's 4. So it's going to be 24 in the sample there. And now we need to work out these two numbers here. Now we're told there's 400 members altogether. So let's add these numbers up together and find the missing one. So let's do 75 plus 100 plus 120 and see what we get. 5 plus 0 plus 0 is 5. 7 plus 0 plus 2 is 9. And 1 plus 1 is 2. So that's 295. So if we do 400, take away 295, that'll tell us this number. So 400 take away 295 is equal to 105. So it means there's 105 members that are 60 years or older. And if we want to work out how many are in the sample, we just need to divide by 5 again. So we're going to do 105 divided by 5. 75 is going to 1, 0, remainder 1. How many 5 is going to 10? That's 2. And how many 5 is going to 5? That's 1. So the answer is 21. And that's it. Okay, let's look at our next question, question number 9. Okay, let's look at our next question, question number 9. So question number 9 says the teacher decides to carry out a survey about school dinners. And she's going to ask students in year 4, year 5 and year 6. And the numbers in the school are shown. So these are the numbers in the school. So there's 100 year 4 students, 120 year 5 students and 135 year 6 students. And a stratified sample is taken if 40 year 4 students are taken. And we've been asked to work out the number of year 6 students that are selected. Okay, so in this question, what we need to do is we actually need to find the sample size. So if we consider the year 4 students, we know there's 100 of them, so that's 100. Out of the total, well, let's figure out the total. So let's do 100 plus 120 plus 135 and see what we get. So 0 plus 0 plus 5 is 5. 0 plus 2 plus 3 is 5. And 1 plus 1 plus 1 is 3. So there's 355 students altogether in those 3 year groups. So 355 multiplied by the sample size. Now I'm just going to call that n for the moment. But we know for year 4 that's equal to 40 because 40 students are surveyed. So that's equal to 40. So the number in the category divided by the total times by the sample size is equal to 40. Okay, so now we just need to solve this equation. So let's give ourselves a bit more room. So what I'm going to do is I'm going to multiply both sides by 355 because I want to get rid of this divide by 355. So I'm going to times the left hand side by 355 and times the right hand side by 355. So on the left hand side, we're multiplying by the 355 to get rid of the divide by 355. So we're going to be left with 100 times n. So that's going to be 100n. And on the right hand side, we need to work out what 40 multiplied by 355 is. So let's do that. So that's equal to 14,200. So 14,200. So we've now got that 100n is 14,200. Now let's divide by 100. So if we divide by 100, we're going to get that n is equal to 142. So that means there's 142 students in the sample. Okay, now what we need to do is we need to work out how many year 6 students are selected. So let's go back up. Okay, so if we look at year 6, there's 135 in year 6 over the total, which is 355. Multiplied by the sample size, which is 142. And when we work that out, it'll tell us how many year 6 students should be in the sample. So 135 divided by 355 multiplied by 142 is equal to 54. So that means there's 54 year 6 students in the sample. And that's it. So just to recap on this question, we were told there's 40 students in year 4 selected in the stratified sample. So we knew that 100 divided by 355 multiplied by the sample size was equal to 40. We solved that equation to find that n was 142. And then we worked out the number of year 6 students in the sample by doing 135 divided by the total times by the sample size, which is 142. And we got that was equal to 54. Okay, let's look at our last question, question number 10. Okay, let's look at our last question, question number 10. So question number 10 says, here's some information about the colour of raffle tickets sold. So there's 490 red raffle tickets sold, 70 yellow raffle tickets sold, and 140 blue raffle tickets sold. And we're told that a sample of 20 tickets is taken and they're stratified by colour. And then we're told from this sample, Jason chooses 2 winning tickets at random, work out the probability that the 2 tickets are the same colour. Okay, so what I'm going to do to begin with is I want to figure out how many of each of the colours is in the stratified sample. So let's work out how many tickets there are altogether. So let's add the 490, the 70 and the 140 and see what we get. So we do 400 plus 70 plus 140, that's equal to 700. So the 700 raffle tickets altogether. Now there's a stratified sample taken of 20 tickets, so 20 tickets. So what I'm going to do is I'm going to figure out what 700 has been divided by to get 20. And if we do 700 divided by 20, that's equal to 35. So that means it's been divided by 35. So that means we can work out the number of red, yellow and blue tickets in the stratified sample because all of these numbers will have been divided by 35. So let's do that. So 490 divided by 35 is equal to 14. So there's 14 red tickets. 70 divided by 35 is 2, and 140 divided by 35 is equal to 4. So that means there's 14 red tickets, 2 yellow tickets, and 4 blue tickets in the stratified sample. Now we're told from that sample, Jason chooses 2 winning tickets, so he's going to choose 2 tickets at random from that sample. And we've been asked to work out the probability that the 2 tickets are the same colour. So we want to find the probability of a red and a red. We want to find the probability of a yellow and a yellow, and we want to find the probability of a blue and a blue. And when we do that, we can add all those probabilities together and ask the probability that the 2 tickets are the same colour. So let's do that. So let's start off with the probability of a red and a red. So the first ticket being red, well, there's 20 altogether, and 14 of them are red, so that's going to be 14 out of 20. Then once Jason's taken that ticket out, there's only going to be 19 tickets left. And 13 of them are going to be red because he's taken out a red ticket. So if we times them together, that'll tell us the probability of a red and a red. So if we do 14, so 14 over 20, multiplied by 13 over 19, that's equal to 91 over 190. So that's the probability of a red and a red. And just to recap that, that's what we done was we found the probability of the first one being red, which is 14 out of 20, and the next one being red is 13 out of 19 because our tickets come out, our red tickets come out, so there's only 19 left and 13 of them are red, and we've times them together. And if you need a recap on conditional probability, that's video 247 on corporate maths, and that'll be quite useful for you as well. Okay, now the probability of a yellow and a yellow. So there was 2 yellows out of the 20, so it's going to be 2 out of 20. And then once that yellow is taken out, there'll be 1 yellow left out of 19. And then if we times them together, we get an answer of. That's equal to 1 over 190. So there's a 1/190th chance of a yellow and a yellow. And then next, a blue and a blue. So the probability of a blue and a blue. So there's 4 blue tickets, that's 4 out of 20, multiplied by 3 out of 19. And when we do that, because obviously there's 4 blues out of 20, one of the blues is taken out, so that leaves us with 3 blues out of the 19. And then if we times them together, that'll be equal to 3 out of 95, 3/95. And then if we add them together, that'll be the probability of the 2 tickets being the same colour. So let's do 91 over 190 plus 1 over 190 plus 3 over 95 on our calculator and see what we get. And that's equal to 49/95. So that's the probability that the 2 tickets are the same colour. 49 out of 95, so 49/95. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on stratified sampling. I really hope you found this video useful. In this video, we've gone through stratified sampling, and if you need any extra help on stratified sampling, if you go to video 281 on Corbettmaths, there's a dedicated video tutorial there on stratified sampling. Again, I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.